This video is about the titration of a diprotic acid. We're going to pick a real nice system, 20 milliliters of 0.1 molar H2A, and we're going to titrate it with sodium hydroxide. I just made up some numbers. Ka1 is 10 to the minus third, and Ka2 is 10 to the minus ninth. So one of the things that you have here is we're going to use some of the information from the last two videos, and one of the big things is that at the intermediate form pH is equal to 1/2 pKa1 plus pKa2, and we'll always use that. Okay, so the first thing to do is find our equivalence point on this, and so I'm going to write the reactions. Already had it written. Here it is. H2A is going to react with sodium hydroxide, and we only go and remove one proton. I'm only removing one of these protons here in our first step. That's very important. And so we'll run this completely to completion. We'll run it till we get only this left. Then, after we've done that, we'll do the second reaction, which is H2A plus, which is HA minus plus sodium hydroxide to give us A minus 2 plus H2O, and I still have a sodium in there, and A plus. So my first equivalence point is going to be the volume of sodium hydroxide needed to get all this first reaction to go. I want to get this to go to completion. So that'll be real easy. You should be able to figure that out. It's 20 milliliters times 0.1 moles H2A per liter times however many moles, it's 1 to 1 H2A per 1 NaOH, because I'm not going both. I'm only doing one proton, and divide by the molarity, which is 0.1 moles per liter, and I get 20. Volume equivalence is 20. So now I'm able to make a chart. That's your first step. Okay, find the first equivalence point. So I'll make a chart, and here we go. I have volume of NaOH. I'm going to make this equations. I screw up and put a 9 right here, pH equal to pKa, for our system. Scroll back down, we do 40 milliliters. I'm going to do 40 and 45 right now. Initial final, we have 2, 2, 0, 0, 0. We have 2 here, not 4, for the same reason. We always use up 2 in the beginning. 0, 0, 2, 2, and 2, and then I'll write down 45 down here. Initial, final. This is how I like to do it. 2, 2.5, 0, 0, 0, 0.5, 2, 2, 2. And so each time I got to look at what I have. So for the 40 milliliters, this should be straightforward. All I have left is A minus 2. And so I do this thing. I do A minus 2. Let's do it down here. A minus 2 plus H2O gives me HA minus plus OH minus. Note the OH, and I make an ice table, and now I got to think I have 2 millimoles, but I can't do an ice table with millimoles, divided by the total volume, which is 60 milliliters, and 2 divided by 60 is 0.0333 molar. So let me fix that. 0.0333 dash 00 minus x and x, and 0.0333 minus x, and and I end up with KB 1, which is KW over 1 times 10 to the minus 9th, KW over KA2, which is, what is it? I have it written down here already. 1 times 10 to the minus 11th, and that's equal to x squared over 0.00. It's not 1 times 10 to the minus 11th. Hang on. It's 1 times 10 to the minus 5. I can't do math. And so I now have 0.0003. I'll get this to work. 0.0333 minus x on the bottom. When you solve that with it, you get x equal 0.000577, and I did one more successive approximation, 0.005720. That's good enough. We're done. And this is the concentration of OH minus. So I scroll back up and I put that number in here, 0.005720. I take the log of it and I get 3.243, and I start panicking because what happened, the pH went down, and then I realize I'm in between my two lines and I go, aha, yeah, that's POH. I need the pH was 10.757. That is such a common mistake. Okay, don't use the POH. And now I got to do the very last point, which is really probably one of the easier ones, if I can find it here. Here it is. I have 0.5 millimoles of sodium hydroxide, and so I just go 0.5 millimoles of sodium hydroxide divided by 65 milliliters, and that gives me 0.007692, and so the pH is 11.88. Remember, this is concentration of OH. Alright, so I put that number in my chart, and then I'm going to copy, and there we go, 11.88. Now we got to make the graph, okay? We'll copy and paste. Okay, I got my copy and pasting. I made my graph. Over here I have pH, and on the x-axis I have volume of sodium hydroxide. And so I start plotting. At 0 I get 2.02 right there. I should put these in a different color right there. And at 10 I get 3. It's going to get a little crowded this time. At 20 I get 3, 6. At 30 I get 9, right about in here. At 40 I get 10.75, not much difference. And at 45 I get 11.88. Now that's almost 12. I should be up higher. Okay, so this, you really have to know the step ladder function. It goes like this. Because it's going to get you confused if you don't think about it that way. So my graph is going to look like this. Up quick, over, up quick, over, up quick, over. Please, anybody giving me this kind of curve is toast. Okay? It cannot be straight line. It has to follow the green curve, not the yellow. That's it. So you should be able to do those homework problems I assigned in Module 2. Have fun.